Andreas Schmittner is a professor at Oregon State University. He has his PhD, so I apologize, Dr. Schmittner, PhD in physics from University of Bern in 1999 in Switzerland. He has been a professor with Oregon State University since 2005. He was the 2006 Early Career Award winner for Ocean Science section of the American Geophysical Union. He is a member of the AGU, the AMS, and the European Geosciences Union. He has published or been a part of almost 100 publications. That's fantastic. If you've read a lot of his stuff, which I know a lot of us in this room have, you understand that he is very well versed in a lot of subjects. Professor Schmittner, like I said, has been with Oregon State since 2005. He's currently teaching and advising a number of students, including our own April Vogt and Tanis Leach, who I wish were here. I know that's, they were some of your favorite students as well. Producing and teaching different classes this year, including paleoclimate, climate science, introduction to climate modeling, the changing climate, man's impact on climate, and introduction to oceanography. Ladies and gentlemen, please welcome Professor Andreas Schmittner.
Thank you very much, Bobby. Thank you, everybody, for coming. This is terrific. I'm so glad to be here. I've enjoyed already some conversations on the table. And so, yeah, I want to talk a little bit about an effort I've been involved with in responding to a recent report from the Department of Energy. They have written a report on climate, and as a climate scientist, I was curious, and I've been reading it, and then a whole bunch of other scientists like me, we felt the need to respond to it. And so I'll talk about a few subtopics in that report that I am particularly interested in or work on, and those are the ice ages. There's something on hurricanes in there that I'll briefly touch on also, and then coral reefs. So those are just a few of the topics in this whole report. I mean, I can't talk about everything, but so those are the ones that I am familiar with, that I've read and that I've built my an opinion about. So I'm going to share that. Yeah, so let's get started. In terms of the content, I'm going to introduce myself a little bit and tell you why I do this. And after that, I have a bunch of slides just on the background science of global climate change. So to get everybody kind of a background of the basics. And before I then go into the details of the report and the scientists' response, and then cover these three subtopics and end up with some conclusions. Okay, so let's see. And before I even start to tell you anything, I want to know what you guys think. So what I have set up is a survey. Yes, if you can distribute those. And so what I would like you to just answer a few brief questions. If you have your cell phone, you can go to this URL. And do you think climate is changing? Just yes or no. If it's changing, is it warming or cooling or something else? What are the causes, natural, human, or both? Is it good or bad, or neither? Should we do something about it? And if yes, what should we do about it? So, brief 6 questions, and after kind of the general introduction, I would hope to look at the results in real time. I hope it works. I think I need internet access for that.
Oh, I have a password for you.
Okay, yeah, so maybe we can go there.
Let me know when you're ready.
What is, do you know the
It's
name?
OSF, yes.
This?
Our password 1969. capital OSF. Yep, and then pound sign.
Pound sign?
Yep, M-I-Z.
Small letters?
Yes.
M-I-Z.
I-T.
I-T, all small?
Yes, H-R-A.
H-R-A.
Yes.
Okay, perfect. Does it work, the survey? Can you enter it? Okay, perfect.
Bobby, did you say this place is got a Wi-Fi?
Yes, I can give you that password. Stand by 1 second.
All right, so while you fill in the survey, I'm just going to say a few more words about myself. You may notice an accent. I'm from Germany originally. I have been here, as Bobby said, since 2005. I'm a climate scientist, so I've been working on this since my PhD in 1999 in Switzerland, and even before that, during my PhD was part of it, and even before in physics in Germany, I did a diploma thesis related. So I've been working it for a long time, and there is this disconnect that I see between what climate scientists know is happening and is causing the climate changes that we observe, and the public perception of it. And there's so much misinformation in the media that I think contributes to that confusion of the public on this topic. A lot of that misinformation is deliberate, I think, and so it's not surprising that the public is confused about the topic. And so what I want to contribute to a better understanding of people. And for that reason, I have written a textbook also that I'm going to introduce to you. So really, almost all climate scientists know that global warming is human-caused 100%. But if you ask the public, this is from public polls, only like 60% or so of the public think that's the case. So there's a big difference and a big gap, and I would hope to narrow that gap a little bit. And here is the website for my climate textbook. You don't need to make pictures. I'm going to give you another URL or QR code for this presentation, and then if you download the presentation, the link should be, you could just click on the link, and then you can access the textbook. Appreciate that. Yeah. I have written this in, hopefully the language is understandable for everybody. You don't need like a math PhD or things like that. So it is for students of all background, even non-science students. So hopefully this is accessible and understandable. Yeah, so that's kind of my goal. This textbook has a lot of additional information other than what I'm going to talk about. So if you're interested, you're welcome to have a look at it. And here is the URL that's also going to be distributed, the QR code, if you can't take a picture from the screen, so that there you can download this particular presentation. And as I said, the link should work in there, so you could just click and access the...
I got a request for access when I tried to click the QR code.
Yes?
Yeah.
You can't? Oh, I'm sorry. Okay, maybe it worked for me because I created it and it doesn't work for everybody else. Well, I apologize.
If it doesn't work, we can get a copy from him and I'll post it on the AMS website.
Yeah, that'd be great. So some basic data. This is the global temperature observations over the last 100 some years, and as you can see, there has been warming of about 1.5 degrees or so between the late the 19th century and the last 10 years or so. And most of that warming happened during the last 50 years. So there's a clear warming trend in the observations. So these are global average surface temperatures over the ocean and over the land. Now, part of, yes?
So I was reading something the other day that said there are only 2 reporting stations now for surface temperature. That's bullshit. Okay?
Two reporting stations only in Africa. I mean, I would doubt it. I would doubt it that there's only 2 reporting stations in Africa. Right?
This was a scientific study. Are these with climate markers? Yes. Are these stations distributed throughout the landmass?
Yes, they are distributed all over the world, and ocean data is also included in there.
And if you go to that,
One point I would like to make, if it is easy. I mean, climate change is a complex subject, and there are so many different informations. It is easy to pick a small part of the data and mislead people. And I'm going to give that example here. If you just look at the data in this black box here, from 1998 to 2012. So if I extract that part of the data, it looks like this. Right? So there's no obvious trend in the data. So if you take just a small chunk of the data, and people have done that, it looks, then they claim there's no trend. Global warming has stopped. And that's what people said in 2012. So really you want to look at all the evidence. It's important to consider all the evidence and not just cherry pick certain data or certain things. This is what the map looks like of the warming. So it is not the same everywhere. We know the Arctic is warming the most. The land masses are warming more than the ocean. This distribution is very robust. It makes a lot of sense. Also, we understand it from the physics point of view, why, for example, land warms more than the ocean and why the Arctic warms more than the tropics. It's not only the air temperature that's warming. These are ocean observations averaged over the whole globe, over the upper 2 kilometers of the ocean. So from the temperature measurements in the ocean, my colleagues, they go out with a research vessel, they lower instruments into the water, and that's the blue curve. And then since around 2005, I think, the red line, these are autonomous devices that float in the ocean, Argo floats, that report back via satellite the data. So those are the red, and then the black curve is the average, like a running mean through those red data. You can see those agree with the blue trend, and everything's going up, right? So the ocean is warming too. And so not only the air temperature is warming, the oceans are warming. We also know where the oceans are warming. They are warming at the surface the most. So that warming comes from the atmosphere. It penetrates the ocean slowly from the surface down. So which is consistent with human-caused greenhouse effect. There's some places where climate change is more obvious than others. In where we live, here in Oregon, it's hard to say from a human perspective that there is a big change happening. But if you are...
I would disagree. I think here the last decade, the summers have gone crazy.
Okay, yes, I mean, some people, especially those who are older, who have more experience, right, have seen other things for a long time. You can tell, but it's still like, it's not like the most obvious everywhere. But some places where it is obvious is the Arctic, and this is the sea ice extent in the Arctic On the left, we have a satellite picture from 1979. That's where the satellite started recording. And then here's a recent one from last year, September. September is the month where the sea ice content is the smallest. And you can see how much that sea ice cover has decreased over those years. It's about, the lost sea ice is about 10 times the size of Oregon. So that's the area of sea ice that we have already lost over the last 30, 40 years, 50 years. And other places where it's more obvious are mountain glaciers, which have been melting, like illustrated here. This is the Muir Glacier in Alaska, but glaciers all over the world, in the tropics, at high latitudes, in the southern hemisphere, everywhere glaciers are melting. These observations are clear, and of course that water from the melting ice sheets and glaciers flows into the ocean. The sea level is rising, and that is also very clear in the data. Sea level rise has not been a lot, but 25 centimeters, so like 10 inches is the amount of sea level rise that we have had over the last 100 years or so. And it's accelerating. If you look at the curve, the rate of increase was lower at the beginning of the record than it is right now. A large amount of that sea level rise comes just from the thermal expansion of seawater, but considerable amounts, like half of it, comes from the melting of the ice. It used to be more from mountain glaciers melting, but the ice sheets, the big ice sheets, Greenland and Antarctic ice sheets, are contributing more and more percentage-wise to that sea level rise. And that is also where so much, more water is stored, so that in the future we would expect much larger contributions from those ice sheets. And we also know the reason for this warming. It is increasing greenhouse gases in the atmosphere. This is the CO2 record from Mauna Loa Observatory here in Hawaii. By the way, the current administration wants to close that observatory in Hawaii. But it's an iconic record. They started taking these measurements in 1958, and you can see the CO2 concentrations have increased from about 300 ppm or 310 to currently we have 430 ppm, and there's no sign that it's stopping to increase. Yes.
What time of year, the seasonal fluctuations in CO2, what time of year is CO2 at its high point in the annual cycle?
At its high point, yes. So this annual cycle has to do with the most of the vegetation is on the northern hemisphere because there's no more land mass in the northern hemisphere. So in the spring and in the summer, the vegetation grows. It takes up CO2, so CO2 goes down. And then in the winter, in the fall and winter, the leaves are decomposing and releasing CO2 back to the atmosphere, so it goes up, so it has a maximum, I would say, like late winter. That's a good point, but this general increasing trend is what causes that warming of the system that we have. And scientists are 100% certain that that is the case. We know that natural variability does not play a role in the global warming that we've seen over the last 50 years. There are sunspot cycles, they go up and down in 11-year cycles. Volcanoes happen once in a while. They do influence climate somewhat, but this trend that we've seen is 100% human caused. And so that is a very well established fact in science, and it has been established over many decades. One other aspect I want to mention in this introduction is that ocean acidification. The red curve is the same that I showed you before, the CO2 from the air measurements at Mauna Loa. Near Hawaii, they're also measuring CO2 in the ocean. That is the green curve. And so, CO2 is a gas. It dissolves in the ocean. And as CO2 concentrations in the atmosphere increase, they also increase in the ocean, in the surface ocean. It's shown by the green curve. But in the ocean, CO2 reacts with seawater and it forms carbonic acid. And that changes the pH. So the pH decreases, it makes the waters more acidic in the ocean. And that is referred to as ocean acidification, which is another problem caused by these carbon emissions, by these increasing CO2 concentrations in the atmosphere. Okay, so that was already kind of a lot, but also kind of hopefully some basic information that many of you already know. I'm going to try to see if we can look at the polls and see what your opinions were.
It's going. Just takes a little bit.
Okay. Well, I'm not sure if it's worthwhile like waiting for it to load, but I think no. Okay, I don't know.
Can I ask you a question about ocean acidification?
Yes.
So is the rate of that, it looked like from your graph it's almost comparable, the slope is downward as the CO2, but
Yes.
there's no buffer, like there's no lag or anything, it's just pretty much as the...
There's no what?
No lag in how
No lag?
Lag.
Yeah, there's some lag for the ocean to absorb the atmospheric CO2. Takes about 1 year for the surface ocean to equilibrate with the atmosphere. So there's about a 1 year lag for the CO2 to enter the surface.
And then the acidification is just right in step
Right,
with
the
that?
chemistry is essentially instantaneous in the
Okay.
ocean. Yes. Mm-hmm.
I thought maybe it differed depending on what the level of carbonic acid interaction with sea life could be. Can we ask you a question about our parking? Yes? Oh, we'll do our parking later.
Okay, we're getting there. It's doing something.
If it doesn't, I can give you my hotspot. Hopefully that's recording. We'll start to give you my hotspot.
And the purpose of this survey was really more to illustrate that we all have different opinions, right? And that is also the case for climate scientists. No? Climate scientists have a variety of opinions on things, but some things we are very, very certain about, and everybody knows what's going on. This is what I told you before. The warming, the causes of the warming, that is well established.
All right, there we go.
What is? Oh, okay, cool. Thank you.
You're welcome.
Where the opinions differ more is, okay, we'll just try it maybe later after it, but where the opinions differ more is really what we should do about it, if we should do something about it, and so on, right? And then I think so there's thousands of climate scientists in America, maybe 10,000 climate scientists in the world. You know, there's a lot of people with a lot of different opinions. And if you, so what would you think if, you know, so this report, this D.O.E. report, it has 5 authors. And climate science is a complex topic, right? From the Arctic to the tropics, there's marine ecosystems affected by terrestrial ecosystems affected by ice changes, sea level changes. What do you think? What would you think of the fact, simply the fact that this report has 5 authors? Well,
Are they qualified? Are they qualified?
Are they qualified? Right. That's a good question. Are they qualified?
IPCC has a problem.
Right. So the problem may be that they don't have the breadth of all the different topics, right? That they may not represent the entire breadth of the different subtopics. So and what the gentleman said is correct. The previous IPCC reports and other reports had many more authors. So the fact that this report has only 5 authors already may be a little bit suspicious. Well,
all the authors work for D.O.E.?
Sorry?
Do all of the authors work for D.O.E.?
I don't think they work for D.O.E., but they have been selected by the Energy Secretary. Chris Wright has handpicked these people, and many of them have a history, and so yeah. So that's the point. You know, the D.O.E. report has 5 authors. Other reports, IPCC reports, have many hundreds of authors. Even the U.S. National Climate Report, the last climate report, has 500 authors. So they can cover the whole breadth of the topics. There are special experts in each individual topic. And just for just to illustrate the fact, I've brought issues of IPCC reports. So this is just, and these are from 2007. So these are not the most recent ones. I don't have paper copies of the most recent ones, but these are. This is one report, or 3 parts of one report from 2007 IPCC. And
How many volumes were in 2007?
Sorry?
How many volumes were in 2007?
I think those are the 3 main volumes of the report. One is about the physical basis, one is about impacts, one is about adaptation and mitigation. And you can see, these are huge volumes. It's hard, and no individual person can read, a whole report like this. But there goes a lot in it. There are many authors, many references cited. So when there is a report with only 5 authors and 140 pages, it obviously it does not compare really with previous reports. And this is my personal view of the climate scientists' opinions. So this is made up, but made up based on my experience with my colleagues going to conferences and such. So there are some that think that climate change is not happening, not a big deal, and nothing should be done about it. And there's some on the other side that think that climate change has catastrophic impacts immediately in the future, and it is pretty much too late to avoid it and do anything about it. So those are the extremes, I would call them. And then there's the vast majority of other climate scientists in the middle who are concerned about the topic and who think that we should do something about it. And I'm part of that green portion here. And the authors that have been picked for this D.O.E. report are from this red population. So they have been picked based on their opinions on climate change, that it's not a big deal, And that is then reflected also in the entire report. So here's the summary of that report. A few points. So I've underlined some parts. The near-term impacts of elevated concentrations of CO2, enhanced plant growth, and reduced ocean alkalinity. Reduced ocean alkalinity, that's the ocean acidification portion that I mentioned earlier. We're going to talk about that with respect to the corals. It finds claims of increased frequency or intensity of hurricanes, tornadoes, floods, and droughts are not supported by U.S. historical data. So that's the hurricane part that I'm going to also cover. So it asserts CO2-induced warming appears to be less damaging economically than commonly believed, and that aggressive mitigation policies could prove more detrimental than beneficial. Another point I would like to highlight here is that finds that U.S. policy actions are expected to have undetectably small direct impacts on global climate, and any effects will emerge only with long delays. So what that says essentially is, if we do anything about it, right, if we reduce our carbon emissions in the U.S. only, it doesn't have any effect. It doesn't make a difference, right? So it's not worth even doing anything. And I would like to come back to this point at the end of the presentation and see what you all think about it. Okay, so now this is the scientists' response to that report. It was organized by Professor Andrew Dessler at Texas A&M, and I have contributed to it. So 85 scientists have contributed to it, and it's 450 pages. And the basic conclusion is in this bold text here. As detailed in the over 400 pages of our expert review, the D.O.E. Climate Working Group CWG report exhibits pervasive problems with misrepresentation and selective citation of the scientific literature, cherry picking of data, and faulty or absent statistics. And I'm going to show you these 3 examples that I've looked at carefully to see what is wrong with that.
Can I get a photo of the map?
Sure.
Can you explain who chose those reviewers? What organization?
This was a self-organized effort. So there's no organization involved. It was self-organized by the scientists.
One thing that sticks out that immediately makes me suspicious is, if you look at North America carefully, the eastern part of the central eastern part of the U.S. seems to have warmed faster than the West, and that seems to contradict everything in my experience that we've had the last couple of decades.
If you refer to this map specifically,
yes.
I don't exactly know what this map shows. It's just the title page of the report, so I can't tell you exactly what is shown in this map. But we can figure it out. But I don't know exactly what that figure shows. So let's start with the ice ages. That's my favorite topic. I'm really passionate about paleoclimate. That's my research. I do climate modeling, and we're trying to reconstruct the ocean during the ice ages. So that is part of my work. I know the paleoclimate data very well. So I would consider myself an expert in this topic. And so let's go back to the last ice age. By the way, what I found fascinating, these woolly mammoths, when they, I don't know if some of you know, but when they remodeled the OSU stadium, the Reser Stadium, they found like a big femur from a mammoth. So 20,000 years ago, can you imagine? These guys were running around here. So pretty amazing to just imagine that. And it was quite a different world 20,000 years ago. There was this big ice sheet over all of Canada, pretty much going into the northern US. There was another large ice sheet over Scandinavia, northern Europe, that we don't. No, yes?
At that time, did the Arctic air masses still miss Portland? That's all we want to know.
They were less modified.
We have an issue with that here.
Yeah, that's funny. And temperatures overall, the map shows reconstructed temperatures were colder. On global average, it was about 4 or 5 degrees C colder than it is than pre-industrial. And locally here, Portland was probably affected by some of the changes, but in the Wallowa Lake, for those of you who've been there, it has these textbook glacial moraines that surround the lake. So those are from the last glacial maximum, and they are gorgeous. And so they essentially are the debris that the glacier that came from the mountains bulldozed all that debris and dropped it at its terminus. This map here shows kind of how the Cordilleran ice sheet extended during that time. So the ice moved pretty much all through all of Canada was covered, and into Seattle. Seattle was also covered by the ice.
Is that year-round ice at that point?
Yes, that was an ice sheet, hundreds of meters of thick. Yes, the Laurentide ice sheet was the maximum height was I would say maybe 3 kilometers or so. So that's kind of similar to modern like Greenland or Antarctic ice sheets. So it's a really thick layer of ice.
In that chart, is that the maximum that they think they went? Because I know
Yes, that's
in the Willamette Valley they have that glacier rock, so a few seem to have come through the Willamette Valley.
That's from the flood.
That's from the flood. What was that from the flood?
But the last maximum was close to the maximum maximum glacier extent.
Okay, so that is okay.
And the reason why these ice ages happened, we also know that from the Milankovitch theory. So it has to do with the Earth's orbit around the sun. The Earth's axis is tilted with respect to the sun. So let's say this is the sun here, and then with my hand is the axis of the Earth. It's tilted 23 degrees. So if the axis is tilted towards the sun, we have summer in the northern hemisphere, right? If it's on the other side, we have winter in the northern hemisphere. And that tilt is not constant, so it changes a little bit. So that changes the amount of sunlight we receive in summer versus winter. And then also so that's called the obliquity. So that's this curve here. It changes on 40,000 year cycle. But there's also precession. So precession is essentially the wobble of the Earth's axis. It wobbles with respect to the orbit around the sun. So let's say this is the configuration today. In 10,000 years, the axis will be on the other side, and that is that's called precession. That varies with 20,000 years per cycle. And then at the eccentricity, so the Earth's orbit around the sun is not a perfectly circle, but it is somewhat oval-shaped, and that's called eccentricity. If this parameter is 0, it's a perfect circle. And see, like 30,000 years into the future, it will be very much more circular than it is currently, but that kind of varies somewhat also, and that is in 100,000 year cycles. So these cycles are between 20,000 and 100,000 years, so very long, very slow changes. And they affect the sunlight in the northern hemisphere. That is that is called Milankovitch theory. That determines the growth and melting of the ice sheets. Because it's the summer hemisphere, it's the summer insolation in the northern hemisphere. Because if you imagine that you have snowfall in the previous winter, if the summers are warm, that snow will melt. Right? If the summers are cooler, some of that snow may survive the summer, and then the next winter it can build up more. Right? So that's why it's the summer insolation in the northern hemisphere is the determining factor for these ice ages. It's called the Milankovitch theory. And the data show, and so these are ice core data. This is the Antarctic ice core record temperature estimates from water isotopes. On the right, we have current, so 0 is the current time. So we're going back 800,000 years. This is in thousands of years. And it shows the ice age cycle in terms of temperature, local temperatures in Antarctica. So Antarctic temperatures have been about 8 to 9 degrees colder at the height of the ice ages compared to today. The red curve is the CO2 record that has been measured in little bubbles in the ice from Antarctic ice. And you can see it goes up and down from 190 ppm to 280 ppm. So by 100 ppm or so, it varies between ice ages and warm ages. And it is very strongly correlated with the temperature record. So the temperature and the CO2 are very, very similar. The blue curve here is the sea level, which is from deep ocean data reconstructed. And here is what the D.O.E. report says about these ice ages. So an application to the well-known Vostok ice core record, those are the data. So this figure is not from the report, it's just I inserted it from my textbook. But just to illustrate the data that we're talking about. The Vostok ice core data revealed an error in Al Gore's documentary Inconvenient Truth. Gore showed the data and drew attention to the coherence of temperature and CO2 changes over the time span, which asserted was due to CO2 driving temperature changes. But temperature changes can also affect atmospheric CO2 levels. Davidson et al. Examined a series and found that temperature Granger causes CO2, but not the reverse. Granger causes, that is a time series analysis. So essentially, it tells you if one time series, if you use that to predict the other one, you can somewhat predict the other one. So what this study finds that the temperature data, the black curve, can predict the red one, but not the other way around. And so then they conclude, in other words, on the time scales represented in the Vostok data, the coherence in the series is primarily due to the influence of temperature on CO2 levels, not the feedback of CO2 levels on temperature. And so what they're saying is essentially temperature affects CO2, but not CO2 temperature. And that is something that we cannot conclude from time series analysis alone. So this conclusion is not, you cannot draw this conclusion based on this paper. And I want to kind of illustrate that these two time series, they vary over long time scales, over these tens of thousands of years. And there is a delay, there's a lag between some of the time series, and that was known for a long time that the CO2 time series, here the red one, that lags a little bit this black time series. And just from that lag, you may conclude that it causes the other one. Right? The leading one causes the lagging one. But that is not, you cannot actually conclude that, because if you imagine you have two time series that vary over a long time period, and there's a small lag that is much smaller than the time period of variations. And here I made this up, it's just sine curves that I shifted a little bit. So if this CO2 curve lags by 500 years, and even if temperature causes CO2 to go down, if once CO2 goes down a little bit, it can influence temperature. And so you cannot tell just from the time series by itself which one causes which by how much. So that is impossible just to infer from the time series. So we need to have some process understanding of the and quantify it differently to understand what causes what by how much. And we have known in paleoclimate literature for a long time that this lag is there. But we cannot conclude that CO2 does not influence temperature. In fact, we do know that ocean temperatures impact CO2. Colder waters, for example, can can take up more CO2 than warmer waters. You're all familiar with this. You know, if you take the soda out of the fridge or the beer or whatever, and let it warm up, the CO2 goes out. So CO2 is more soluble in colder water, and that is part of the reason why CO2 was lower in the ice ages. But if you quantify this effect, it can only explain 25 to 50% of those CO2 variations. And we have just a few years ago, we published a paper about this, where we've revised that. So previously, people thought it was only like explaining a quarter of the CO2 changes, but what we've shown is that it actually explains more than half, or about half of the CO2 variations. But still, the temperature changes does only explain up to half of the CO2 changes during the ice ages. So other processes that must have also contributed to those CO2 changes, and those are presumably iron fertilization from increased dust supply and ocean circulation changes. So temperature changes do have an impact on CO2, but only part of that CO2 is explained by temperature changes. On the other hand, we know that CO2 variations impact temperatures due to the greenhouse effect. And that also causes about half of the global warming and cooling during these ice ages. So the global temperature changes were about 4 to 5 degrees. So about 2 degrees, 2.5 degrees were caused by these CO2 variations. So in our response to the D.O.E. report, then we say that this section is contrary to the vast majority of paleoclimate literature, which has established that atmospheric CO2 has an important influence on global temperatures during past ice age cycles. So what they essentially say is that CO2 is not important. But that's not the case. In fact, the paleoclimate literature knows that CO2 is very important for paleoclimate changes during those ice ages. That does not mean that temperature does not influence CO2, right? It's both ways. So temperature influences CO2 and CO2 influences temperature. It goes both ways. Yes?
But it seems like there's a simple, like, what about Venus answer to this too? Like, it's not colder there, and there's a lot of CO2 in the atmosphere. I mean, is that too obvious to just contradict that idea that it's a high CO2 atmosphere and it's a warmer planet?
Venus, yes, has a CO2 atmosphere and it's warmer, but it's also closer to this.
But you can even take that into account, right? As you calculate how much warmer it is, or is that not?
Well, but I mean, this is about Earth's temperature, and Earth's temperature changes, so it's a little bit, yeah. You cannot directly like infer from like Venus what happened on Earth. But anyways, we cited all these papers here that they did not cite in the report, and that show how important the CO2 variations are. I think I'm going to skip over this. This is kind of detailed graphs from one of the papers that show that CO2 really does have an impact on the ice sheet evolution in a model. Maybe we can come back if there's some interest. Also, another issue with that argumentation in the D.O.E. report is that they only refer to the Vostok ice core data, which is local temperatures in Antarctica. But there is a paper, so in terms of global temperatures, so it doesn't say anything about global temperatures, because we don't know global temperatures over those 800,000 years. Where we do know global temperatures is over the last 20,000 years. There has been a reconstruction by Jeremy Shakan from our group at OSU, and he has reconstructed global temperatures, which is the blue curve here, over the last 20,000 years, so a much shorter time period, just from the last glacial maximum to today. The yellow dots are the CO2 concentrations from the ice cores, and the red curve is the local Antarctic temperatures. So that's the ice core record that I showed you earlier in the long record. So the Antarctic temperature and the CO2, you can see they go up almost simultaneously. They are very, very tightly coupled. But the global temperature lags both CO2 and Antarctic temperature, right? So for this time period where we do have global temperature estimates, there's actually a lag in global temperature after CO2. So, you know, you cannot infer from the Vostok record that CO2 has no influence on global temperature. Okay, so I think that's the paleo kind of portion of it. Are there any questions on the paleo? Yes.
In the beginning, I had a question about paleo.
Do you want to ask it now, or
It doesn't matter, whatever you want.
we can do it now or later after?
I'll do it now. You go back to, you had a graph that showed the rise in global temperatures for the last 50 years.
Yes. This
Yeah,
one?
that.
Mm-hmm.
The units on the left, or the unit used, well, actually that shows, you had one that showed joules as units.
Joules, that's the ocean heat content. Yes.
Water temperature, yeah.
The heat content of the ocean.
So my question about that is, we know that there's been some warming, but in those joules that cause the warming of the ocean, how did you separate the CO2 signal from solar radiation, clouds, and water vapor?
Well, this is not separating anything. This is just based on temperature measurements in the ocean.
That's
So
right.
it's just observations of temperature measurements.
That's right.
And to convert from degrees Celsius to joule, you just multiply by constant heat
I'm not talking
capacity.
about how you convert it, I'm talking about how you separated all the signals. And
You
I'm
cannot
saying-
separate it. It's not
I know,
separated.
But you're inferring that the reason why that warmed is because of CO2.
Yes.
But how do you know that?
Well, because it is warming from the surface down. It is, if you look at the spatial distribution of ocean temperatures, the largest warming is near the surface. So it's warming from the surface down. And you know, there have been claims that the warming that we see at the surface is due to ocean circulation changes rather than CO2. And if that was the case, that would mean that you take some heat from the deep ocean, put it in the surface ocean. That could potentially warm the surface ocean, right? By changing the temperature distribution within the ocean, putting more heat from the deep ocean to the surface of the ocean. But if that was the case, you would see a cooling in the deep ocean. That's not what we're seeing. We're seeing essentially no temperature changes in the deep ocean and a large warming near the surface. It's surface amplified. So the closer you get to the surface, the warmer it is.
But
So that's
CO2's radiation gets absorbed at the top of the ocean within like a fraction of a millimeter. It's completely absorbed. Solar radiation will go down as much as 100 meters, and IR radiation from clouds will do about the same thing. It's absorbed very quickly. So you've got rays of sunlight passing it that can cause a warming. And if you look at the change in Earth albedo, it's been about 1% since 1984. Do the calculation on that, and you get almost a perfect map of the amount of warming that we've had. So I don't see how you can separate that.
well, as I said, the warming, the greenhouse effect is established. It's established that if you increase CO2 concentration in the atmosphere, it essentially acts like a blanket because it prohibits radiation from leaving the Earth to space. That warms up the Earth just like putting a blanket around you. And that warming of the Earth's atmosphere then warms the ocean's surface. So that is all what I'm saying, you know, regarding to the ocean data. But let's move on to the hurricane portion of this.
Well, there was one too that you did about the temperatures where you criticizing skeptics for saying that in the 90s they were calling no climate change at all. There was no warming, and the temperature showed that there really wasn't any warming during the period we were talking about. And you said they flew over that and just said they're only looking at that period. Well, that's true. They look at that period, but I've read all the literature. And the reason why they focused on that 10 years was not because they were ignoring what was happening on both ends around it. The reason why they did it is because the models didn't pick up on it. They failed to predict the level off in temperature.
Well,
That's just one of the main problems, one of the many problems you got with the model.
Well,
And if
that's not a fair assessment. I'm sorry, but that's not a fair assessment because you cannot expect the models to simulate the variability in the data. But the models are very good in explaining the trend. The models are spot on in explaining the trend of the warming that we see in the temperature data and also in the ocean temperature data. So the models are very good, and I'm going to stop this now because I don't want to monopolize your questions here, please. We can talk more after the talk after so in terms of hurricanes, the DOE report says the following. Most extreme weather events in the US do not show long-term trends. Claims of increased frequency or intensity of hurricanes and so on are not supported by US historical data. So essentially what they're saying there's that the hurricanes have not changed. You don't see any change in the data in the hurricanes. And that is true. And scientists have known that for a long time. But there's something missing here, which is in our response, the scientists write, although no trends in the number of hurricanes making landfall in the US have been detected and none were expected, hurricanes are becoming more hazardous. They are reaching higher intensity and intensifying more quickly. Higher sea levels are making the coastal flooding more extensive and damaging. Atmospheric warming is leading them to produce more rainfall, which is increasing their inland impacts. So in other words, climate change does not change the number of hurricanes there are, but it changes the impact, the damage that those hurricanes do. Right? So there's more rain, more water vapor in the air, more rainfall. Sea level has increased, so the flooding will be worse. So those things make hurricanes just more damaging. So this is something that the DOE report does not mention. It leaves out the things that show the damage, but it only that's the cherry picking part. It's only taking those facts that seem to fit into their narrative. Okay, corals. How much time do we have?
We have about 15.
15 minutes? Okay, I'll try to go through this. Coral reefs are amazing places. I don't know if anybody has been diving in one or scuba diving or snorkeling even. They are like wonders of the world. There's only less than 1% of the ocean is covered by corals, but they harbor 30% of all marine species. So it's incredibly important for biodiversity in the ocean. Many people depend on it. About 500 million people, maybe even 1 billion people, rely on coral reefs. They provide goods and services in trillions of dollars per year. They provide food in terms of fisheries, tourism, coastal protection from storms. There's even cancer treatments that have been developed based on organisms that live in these corals. So they are just amazing. So what does the DOE report say? Elevated CO2 concentrations make oceans less alkaline, lower the pH. That is possibly detrimental to coral reefs, although the recent rebound of the Great Barrier Reef suggests otherwise. And this figure is from the report, and it shows the coral cover over 3 sections of the Great Barrier Reef. And you can see the tip here, and then it goes back up. So overall, there's no decreasing trend in these data, right? So what I did, I went to this website where this data came from here because I was very surprised to read this. And if you continue reading this, essentially it reads like there's no problem with corals. Corals are just fine, which is contrary to all that I've heard from coral specialists, from scientists like Mark Hickson, who used to be at OSU. He goes there, dives the coral reefs, and he knows what's going on with coral reefs, and he tells me they're in big trouble. So I was so surprised by this, so I looked at this website, and so if you do that, if you just go to the website of the data that they quote there, you can see, you can find information like this about coral bleaching events that become more and more frequent in the recent past. And there's text like this: the point of concern is the increasing frequency and extent of bleaching events. Mass bleaching events are occurring almost annually and pose significant risks to the future conditions of all coral reefs in the Great Barrier Reef. This information is not mentioned in the D.O.E. report, right? Nothing. It just says corals are fine. But that's not actually
What was
the
their,
case.
what was their y-axis on their increasing?
In this,
Yeah,
thi-
yeah.
this is the coral cover percentage. So it's hard to see. It's
Yeah.
like 30% of the reef is covered in hard coral, which is an index of coral health.
But it could be bleached,
It could be bleached, yes.
which removes the whole connection to the fish it depend on.
So what is coral bleaching? For those of you who don't know, coral are polyps. They are little animals that live together. They have symbionts. Those are algae. And those are, the symbionts is what makes corals colorful. But that symbiosis is kind of delicate. And if temperatures get too warm, the coral expel their symbionts. They're called zooxanthella. And then they look white, which is why it's called bleaching. Bleached coral can recover, so it doesn't mean it's dead, just if it's bleached. But if there's bleaching in subsequent years, it can lead to death. So the more frequently bleaching occurs, the more likely is that a coral will die. And there's a global monitoring report. These are global coral cover. It's the same index here. Coral hard cover in percent. This should be like 35.05. That should be 35% covered. And the blue line here is the same that we saw before. So it's the percent coverage. And there in that blue line, you can see the decreasing trend. This is global coral, not just the Great Barrier Reef, right? So global. So if you look at global coral cover, there has been a loss of 14% since 2009 and 2018. So while at the Great Barrier Reef, there may not be a trend. Globally, there is a trend, right? So they select the data that they like. They want to show it's not a big deal, right? So they cherry pick data from one region where there is no trend. But if you look at the global data, there is a trend, and it does not look good. And these red stripes here are the bleaching events, where you can see they become more frequent in the more recent past. So IPCC report has very dire projections for coral reefs. It is projected that for 1.5 degree global warming from pre-industrial, 70 to 90% loss of coral cover will occur. For a 2 degrees warming, 99% loss is predicted. And so the corals will change from like the historical complex reef to a low diversity reef and a degraded reef, and finally, there's no coral anymore at all. So this is from the IPCC report. This is from the specialists, the coral experts who write this. So are corals okay? No, they're not. And no need to read all of this. I have put a few videos here from experts, coral experts, that I've watched in the last few days. Ulf Goldberg here from Australia, Terry Hughes from Australia, Mark Hickson, I mentioned earlier, a colleague from OSU, is now in Hawaii. Feel free to look at them and make up your own mind. But what I hear those experts say is corals are in deep trouble. Ocean acidification is not only affecting corals, it's also affecting all marine organisms that build shells out of calcium carbonate. So this decrease in pH makes it harder for these calcium carbonate body parts to be formed. And it also dissolves calcium carbonate more easily. And there's many experiments that have been done with where you can see the dissolution of some of those. These are pteropod shell up here. It's called the sea butterfly. It's this creature here. Coccolithophores show malformed platelets. Those are phytoplankton in the ocean, so this is food at the base of the food web. It affects oysters in Oregon. My colleague Burke Hales has worked with oyster farmers to help them to avoid these acidic conditions because they made their oyster larvae die essentially. So they have to treat their water now to reduce the acidity, and it also affects other creatures, Dungeness crab, for example. That very little is known how it actually affects Dungeness crab, but there is some evidence. This is from a NOAA website that it's not a positive effect on the crabs. And these were just 3 examples. The scientists have looked at all of the report, and this is from the Carbon Brief website, where they highlighted in orange and red misleading or false claims. So there's more false and misleading claims, and there's reports that are actually not false or misleading pages. So this report is totally bogus. It's totally misrepresenting the science. And the American Meteorological Society, the US organization, agrees with that. So they have written comments. So it lacks breadth across scientific fields, which is what I tried to mention earlier. You need the expertise, like from coral scientists, for example, to evaluate what happens with corals, right? None of those 4 authors was a coral scientist. So maybe you can't blame them, they don't know anything about corals, but they write something about corals in the report, right? But it's not from the actual coral scientists. The lack of depth within scientific fields and specific topics. The D.O.E. report is based on an unrepresented group of subject matter experts, which is what I mentioned. Those are the ones that think climate change is not a big deal, we shouldn't do anything about it. So they have that opinion. With that opinion, they write the report, and the outcome is what their opinion is, and what the Secretary of Energy wants, and what Trump wants. So they essentially give Trump a report that he can then use to have fossil fuel-based extraction, more fossil fuel-based extraction, more CO2 emissions into the atmosphere, no more green energy, no more renewable energy. They even removed existing in-progress windmills, right? They are so aggressively going against solar and wind energy. It's incredible.
Hey, do they shorten the report to less than a page so the president can read it?
I guess that summary is what they'll show him, that these 5 points, that it isn't a big deal, It was
I'm
overblown.
surprised he is able to read even that much.
Yeah.
You've got a question about
Yes.
Yeah, I was just wanted to quickly share a 35-year experience that I had. The first time I snorkeled was about 40 years ago.
Mm-hmm.
And I remember, and several times within, say, a 10-year era, and the color and everything just took my breath away. I just couldn't believe it. I thought it was more exciting than the fish.
Mm-hmm.
So anyway, in recent times, I went to a couple, just inadvertently over like a 5-year period, to 2 places I had been long ago, and I couldn't believe my eyes. There was no color.
No
This was
color?
in Hawaii.
In
Yeah.
Hawaii. So you saw coral bleaching there? Did you see
Yeah, there was no color.
Yeah.
I couldn't. I was looking. I was all excited about going again to these couple of really
Yeah.
cool places.
Yeah.
And I took the adult grandkids now,
Mm-hmm.
and it was such a disappointment,
Yeah.
such a shock.
Yeah, and we're losing these.
No
These-
color.
Yeah, these places. We're losing them.
No, now we know where it went, right?
Yeah.
Oh my gosh.
Does this report give the administration any legal cover to do policy things, or is it just?
Yes, I think it's designed to revoke the endangerment finding of the EPA. The EPA has, I can't remember when, but they found that greenhouse gas emissions endanger the public health, and they want to revoke that, so that it makes it essentially much harder to do any kind of legislation to or regulation to reduce carbon emissions. The national academies also commented on this same topic, and they affirm that human-caused emissions of greenhouse gases threaten human health and welfare was accurate and stood the test of time and is now reinforced by even stronger evidence. So all the scientific organizations, American Meteorological Society, National Academies of Sciences, Medicine, and Engineering, they push back. Okay, this is good, I think. And I think it hopefully, it has an impact. You can read, what they write about it, but it's essentially the same thing. They all condemn this D.O.E. report. So let me come back to finish just what I mentioned earlier. What do you think about this sentence? U.S. policy actions are expected to have undetectably small direct impacts on global climate, and any effects will emerge only with long delays. So essentially, it doesn't make any difference if we reduce carbon emissions.
That's
So why?
That's not what that says.
Sorry?
That's not what that says. It doesn't say it doesn't make any difference.
Well, okay, but it says any effects will only emerge with long delay, so it downplays the small direct impacts, undetectably small direct impacts. That is essentially say it doesn't make a difference to me.
No, okay, that's your interpretation. That's not how I would.
No? How would you
I
interpret
would
it?
interpret it like it says it is. Undetectably small impacts in the global climate, any effects long term, that they will emerge over long delays. I'm not
Yeah.
saying I agree with it. I'm just saying that I wouldn't interpret it the way it is.
Okay. Are there any thoughts on this? Maybe from somebody else?
I think the statement above that is also important because it suggests we shouldn't do anything. I mean, I'm holding the mitigation book here from 2007. It probably, sets on a lot of shelves, and mitigation is tricky. And I think when you showed your self-designed review of, there's no harm, like this is saying, there's plenty of concern and we should do something with blue, almost fatalistic.
Mm-hmm.
I feel like what the shift I see is that when there was concern about geoengineering as a solution before we solved the problem, the cause of the problem, it was legitimate to say, don't get ahead of yourself. I mean, you can't geoengineer out of something that you're still doing. But now I think there is a certain sense that mitigation strategies need to be broader and consider things that might have seemed risky once, but if there's more of a sense that it's not going to be a long delay, it's going to be a short delay before we start to see strong effects, then that's really the question, like what is the right approach to mitigation?
What is the right approach to mitigation?
Yeah, and I noticed your survey didn't give us a lot of choices.
Yeah, no, that's kind of a fun, I don't know, it wasn't very serious, but.
But this is also like that. It's like they're harmful. Mitigation is harmful, more harmful than
Right. So they claim it's harmful. Aggressive mitigation strategies could be more harmful than beneficial. I think you could also exactly claim the opposite. I mean, this is not even a statement that is based on any evidence. It's just, it could be more harmful than beneficial. Anything could be more harmful than beneficial, but it could also be more beneficial than harmful.
Right.
It doesn't say anything really.
Right, and it depends on the strategy, which is the question. That could be the discussion that could be being had by the Department of Energy instead of something like this.
Well, that begs the question, who is it beneficial to? So, we have a system that is driven by profits, then we're gonna protect those that make it.
Mm-hmm.
That's the point.
Yeah.
But only profits for some subsectors, because if you talk to the insurance industry, they might be like, there's a problem for us. We can't insure people if we can't predict the harm that might come, so that we balance our charges.
I mean, yeah, this is an argument about the economically benefits or harms, right? But those are even more uncertain. I mean, the economic, we do not know. It's so difficult to quantify how much harm climate change will affect the economy. There are many studies that say it does, do a lot of harm, but the uncertainties are so large. I mean, it's. I don't think it is very meaningful, those studies, really, from what I've seen.
Two-part question for you. First one, is there anything in this report that you agree with?
You could probably find some things that I agree with. Yes.
Okay.
Mm-hmm.
Second part question, and I ask this anytime I go to climate speeches. What are some actionable steps that we can take right now that may be considered small, but would have a larger impact?
There's a lot of things that we can do. I mean, first of all, we can try to not produce a lot of carbon emissions. We can ride a bike instead of taking the car, or we can recycle. We can drive a fuel-efficient car rather than a gas guzzler. We can avoid plane trips. We can. I think those individual things, although they have very limited impact, I think what is more important is that we elect politicians who do regulation on a nation base and who lead globally the efforts to reduce carbon emissions, because it's not just carbon emissions not just by the US, they're by the globe, by every country, and we need to work together with all countries to reduce those emissions if we want to get a grip on this. So really kind of that supporting those politicians who support the climate action, and also speak out about it. You can, for example, contact your representative and say, this D.O.E. report is really abysmal. It should not be considered. It should be rewritten, and it should be rewritten by real scientists who, not just by a handful of picked ones that have one opinion. So maybe those are a few things that we can do.
Real quick. Go ahead. We have time for 2 more questions, and then if you guys, all of us came in, they are going to help us validate parking. It does take a second to do that, so we'll have a server come in with an iPad. They'll be able to validate your parking ticket so you can get back out of the line.
So this is maybe more of a legal question than anything, but if this report is used to justify change in the EPA's mandate to reduce greenhouse gases, I'm sure it will be litigated.
Mm-hmm.
And is it going to turn into, it seems like it's going to turn into something that a judge is going to have to decide whether a report like this is credible.
Yeah, it could be.
They're going to have to, a legal expert is going to be forced to make scientific judgment.
Well, they can also ask for technical assistance. Judges can be expected to assist them with questions.
So
And they do.
Question the will, yeah.
She get representatives. I'd say not.
We don't get to see.
Yeah, that's true.
I think, Andrew, that you're not quite understanding why they wrote this. If you take a look at what's happened since this.
I don't understand why they wrote this.
No,
Well, I have read it, so they say why they wrote
I
it.
don't think you understand the point. The point that they made in all of this is, we have been at the recommendations of Oregon State University, University of Washington, many universities, the climate carbon reduction programs that have been implemented by politicians. And how did that work out for you guys? California has them, Washington has them, Oregon has them. They're all over the country, building windmills, renewables, and everything else. And the point of that D.O.E. thing that they brought up was, we have spent trillions of dollars on this to date, how's that changing the CO2 level? How is it? It's not changing at all. It's not even
Right.
detectable. It's still going up, and it'll continue to go up. There's 4 new papers that came out, have you read them, that are even questioning what percentage humans are responsible for the increase of CO2 in the atmosphere.
Okay, does somebody have an opinion on that? So essentially, he's just repeating what they say there. It doesn't make a difference what we do, right? It doesn't have an
Sir,
impact.
I have a valid question for you. With those increasing renewables, which have been going up, and interestingly, as long as costs haven't come down, consumers are arguing against them, what fraction are they still of the total energy use? If they're still a small fraction, then we still have a lot of fossil fuel contributions to this problem.
No, right now the renewables are increasing to the point where the electricians that are monitoring the electrical grids for like even the state of Oregon, and it's already happening in California, they're getting brownouts and blackouts because of conversions of renewables. There's a whole lot of stuff that's been spent on this, and it isn't making a ditto difference to the carbon dioxide.
So here's my answer to this. Imagine we're all smoking in this room. Everybody is smoking, okay? Just imagine it for a second. Windows closed, we're all smoking. Then somebody says, maybe that's not such a good idea to smoke. You know, it's really unhealthy. I have to cough all the time. And then somebody says, well, why don't you stop smoking? And then, well, it doesn't make a difference if only I stop smoking, right? If everybody else doesn't do anything, it doesn't make a difference. That's the same argument. It's the same argument.
Yeah.
Yes, it is. So it does not make a difference if only one person puts out the cigarette. But if everybody agrees, right, if there is like common agreement, like there was with the Paris Agreement was trying to set goals to reduce carbon emissions. Then we can do it if we all work together, all countries, right? But if a big emitter like the US exits the Paris Agreement, one of the biggest emitters in the world, it's not going to work, right? So we essentially make the Paris Agreement fail by canceling.